In this video, we provide an overview of information and data models. An information model is an abstract, formal representation of entities that includes their properties, relationships, and the operations that can be performed on them. The main purpose of an information model is to model managed objects at a conceptual level, independent of any specific implementations or protocols used to transport the data. Data models, on the other hand, are defined at a more concrete level and include many details. They are intended for software developers and include protocol-specific constructs. A data model is the blueprint of any database system. The figure illustrates the relationship between an information model and a data model. Information model proposals can be split into 9 historical epochs: network, hierarchical, relational, entity relationship, extended relational, semantic, object-oriented, object-relational, and semi-structured. Let us go over each one of these in the following slides. In a network model, a child can have more than one parent, and each record type points to each other with next, prior, and direct pointers. The figure here shows the record types represented by rectangles in a codicil network. A collection of record types and keys form a codicil network or codicil database. To know more about this codicil database and network, refer DB2 Fundamentals book. The hierarchical model organizes its data using a tree structure. The root of the tree is the parent, followed by child nodes. A child node cannot have more than one parent, though a parent can have many child nodes. This is depicted in this figure. The first hierarchical database management system was IMS, which stands for Information Management System, released by IBM in 1968. It was originally built as the database for the Apollo space program to land the first humans on the moon. IMS is a very robust database that is still in use today at many companies worldwide. The relational data model is simple and elegant. It has a solid mathematical foundation based on sets theory and predicate calculus and is the most used data model for databases today. This figure illustrates an example showing an entity relationship, that is an ER diagram, that represents entities or tables and their relationships for a sample relational model. In the mid-1970s, Peter Chen proposed the entity relationship data model. This was to be an alternative to the relational, codicil, and hierarchical data models. He proposed thinking of a database as a collection of instances of entities. Rather than being used as a model on its own, the ER model has found success as a tool to design relational databases. The object relational, that is an OR model, is very similar to the relational model. However, it treats every entity as an object, that is an instance of a class, and a relationship as an inheritance. Object relational databases have the capability to store object relationships in relational form. The last decade has seen a substantial amount of work on semi-structured, semantic, and object-oriented data models. XML is ideal to store semi-structured data. Object-oriented data models are popular in universities but have not been widely accepted in the industry. However, object relational mapping, that is ORM tools are available which allows a seamless integration of object-oriented programs with relational databases. This ends this presentation. Thank you for watching. To learn more, visit db2university.com.